Okay, this is Introduction to Internet Protocols for my students who are getting ready to study networking, or if they haven't already gone into it. I want to talk about some simple protocols um, that you'll be learning about, and maybe this concept will help put things in the right order. Okay, so first of all, we'll be talking about TCP and UDP. We'll be talking about Ethernet frames, ports and port numbers, and IP addresses, and how all these things come together to actually create a link of communication between two devices or more. Okay, so let's delve right in. Now, I'm sure you've heard of the term the information highway. Uh, it's basically the internet, right? So, the way we're going to look at networking or the communication between devices as an actual highway, it's the same concept. Um, Over the years, we have created hardware and software to act as a way to move data across vast distances as if it were a transportation system. And most of the time, we use Ethernet cables um, as a way to connect one computer to another or to a server, right? Especially in a LAN environment, a local area network environment. So I want you to think as an Ethernet cable as the actual highway between two devices. All right. So on that highway, of course, we're going to have vehicles, right? So I want you to think of moving data that's going across these Ethernet cables as trucks, giant trucks, um, with a bunch of storage pods that are on the back of these flatbed trucks. Now, inside these pods are more boxes or crates, mind you, okay? So they're giant crates that hold all the other contents inside. And those contents we're going to call your data, okay? Now, these crates, we're going to classify them as UDP and TCP. And we're going to go a little bit further, and we're going to notice that the boxes are different, okay? Um, the TCP boxes are more like metal reinforced boxes, while the UDP boxes are a little bit more flimsy, doesn't hold much. Uh, you can't do much with them, okay? And I want you to keep that in mind as we go through this on how this works, okay? So like I said before, inside these crates, we want to think about boxes or blocks or just a lot of application information, okay, that your system needs in order to take this data and make it useful, all right, whether you're sending it or receiving it. All right, so let's put that aside a little bit, and let's just say that inside those crates is all the information we need to send the data. All right, so but in reality, we don't have multiple crates and boxes that separate all the information. Normally, we use an Ethernet network to send and receive data using internet protocols. IP is nothing but a suite of network protocols that connect computers together and sends data back and forth from these connections. These sets of protocol uses either TCP or UDP that contain our application data within its structure to move data across the network in what we call packets. And inside this packet, what we have is a Ethernet frame, okay? And usually the Ethernet frame has a few things in it. So let's take a look at how two computers would connect to each other on a network. It would send an Ethernet frame from computer A to computer B over a network cable. This frame would begin with an Ethernet header and an end with an Ethernet trailer. And in the middle, we would have the Ethernet payload. This would be your crate, okay? And the Ethernet header and the Ethernet trailer is kind of like the wheels on the truck, all right? So inside the Ethernet payload, you would find inside the Ethernet payload, you would find the IP header with the IP payload. Within the IP payload, we can break it down even further to the TCP or the UDP header with the payload. This reveals the payload as an application data that is being sent over the web server. So basically you have this Ethernet frame, there is an IP address, which is like 192.168.5.0, which means that it can find where it came from and or actually who it belongs to, okay, which would be your address. And the IP payload actually tells you whether it's going to be TCP or UDP for the delivery service. So it's basically saying UPS or FedEx, basically. So, and then within that payload is the actual package that you're delivering, and that package would be web server data. All right, it can be part of an email or a document, anything like that. Okay, so TCP and UDP are the containers in which all of your data is carried throughout the network. They have different uses and abilities on the type of jobs that you want them to perform. Once we start putting protocols within protocols, we call that encapsulation. So you would have like UDP, and then you can have another protocol with that in order to find the correct application or service that you need this packet for, or frame for. But UDP and TCP are those containers that carry the rest of the protocols across the internet. Think of TCP and UDP as the actual vehicle that drives. It's like the engine that drives the wheels that goes down the internet, or down the road of the internet. All right, so that is why it is listed on the layer 4 as the transport layer in the OSI model. You're not going to go through the entire OSI model with A+. You will in Network Plus, but here just know that it is layer 4 on the transport model. On the OSI model, okay? And it's considered transport, okay? So that's why TCP and UDP encapsulates other protocols and data for those types of applications, because it carries them with them, and then once your application or service starts unpacking the stuff, it will have other protocols that tell it what to do. All right, so these protocols and applications span across the network or on the internet, or both, using many protocols and applications using the same connection. This is known as multiplexing. So basically, once you establish a connection, you can have protocols going back and forth on this line of information, going back and forth. Like, think of it as a bunch of trucks going back and forth, transferring information for applications or services. All right, so let's take a closer look at TCP and UDP. All right, TCP stands for Transmission Control Protocol. It is a connection-oriented protocol. That means that there are standards that must be met when you begin and end communications. Think of it as a hello and a goodbye in a conversation. It is considered reliable. If a connection is lost during communication, then the protocol starts reconnecting and resending the lost data. TCP is probably the most common used protocol out of the two, most of the time. This is possible because TCP requires an acknowledgement response from the recipient that the data was received successfully. If it does not receive the acknowledgement, then the data is sent over and over again until the sender receives the acknowledgement. TCP is also good with piecing together out-of-order data that belongs to an application. So what happens is documents, certain web pages are too big to be sent over the internet to your computer all at once. So what happens is it takes pieces of those documents and breaks them down, or that web page or whatever it is you're trying to send, or that picture even, and they send it across the network. So once it gets disconnect or taken apart, it doesn't have to be sent in order, because TCP actually keeps a log on the order in which it puts it back together. So it's really good at puzzle of piecing the puzzle back together. So TCP is really good at that. Now what happens with TCP is that since it does all these functions, it takes longer to use. And for some programs, all they need is something quick, something light that they can push through the internet and get to work, like video, like with Skype. Skype uses the other protocol, UDP, right? Because it's connectionless. Let me go back to the beginning. UDP stands for User Data Protocol. Okay, there is no hello or goodbye from them. It's not as reliable, and it cannot recover or reorder and retransmit any of the data. If you want to retransmit the data when you're using UDP, you'd have to retransmit the entire document or email or whatever if you're using UDP, which I don't know why you would. But like I said before, UDP is more for connectionless type of applications that don't need a heavy overhead of usage with connectivity and whatnot. So with UDP, the sender's application just sends the data one way without the need for any pleasantries. This doesn't mean that the data doesn't get to the destination any worse or better than TCP, but the message is never acknowledged as being received. All right. IP is the truck that delivers the data from one location to the next. Think of IP as the FedEx truck delivering mail from one address to another. Okay, like every house, a computer has an address that can be delivered to a network. So let's just say you are moving and you labeled all your boxes ahead of time, right? And these boxes are delivered to your new home. As you are unloading these boxes, you have movers that help you, and the name of each box tells you where these boxes go, right? Well, think of these labels as port numbers instead of kitchen or bedroom or living room, okay? And this data can be delivered to the correct room, right? Well, those rooms you want to think of is as ports. So when you come up with a box with the data or service that you need done, you're able to put it in the right port for that service or application to actually use on your system. All right. IP uses ports as a way to assign services to applications. These numbers are fixed and have certain rules or protocols that applications use to send, receive, and manipulate data to and from your computer. Port access can be risky as well. They grant or deny access to services which can allow changes to your system. If you have a firewall, this is sometimes why an application will not work on your system, or why you might not receive like an email if you actually block a port on your computer. All right. Now, these ports do not physically exist on your computer. They are assigned logically from the Internet protocols and allow your operating system to process application functions. The important ports are already predetermined and used universally across the Internet on every computer system and server in the world. This makes it possible for all computers to communicate and exchange data between servers and clients. A+ will expect you to know them and how to troubleshoot when these protocols fail to work within an application. So when you have an IP address and a protocol like TCP and the port number that it is assigned to, you have what is known as a socket. Think of a socket as an ability to plug into a system, all right? Whether it is a server or a client, you have the ability to establish a link to an application on that system. So we use ports for everything. There are so many ways applications and servers need to access your system that they had to create two different types of ports to handle the server side and the client side. The first set of ports are the non-ephemeral. They are port numbers that range from 0 to 1023, and they're all assigned for a certain purpose. These rarely change and are considered permanent. They are usually on a server or a service that you would need to run an application for. You don't need to memorize all 1024 ports, but there are certain ports that you will need to memorize for A+. We will get to those on a later date. The ephemeral ports are temporary ports that servers use to communicate with a client in real time. There are well over 64,000 of those ports. Chosen at random, the client's main purpose is to create a session while communicating with the server. Now remember, TCP and UDP is the transfer protocol. These are the boxes we put all our data in and transfer them into specific rooms. Therefore, all ports are considered to either have a UDP or a TCP signature, which is determined by the application or server. These ports can be any numbers between 0 and 65,535, because that's how many ports are on your computer. Now, try not to get hung up on what the ports are. They are just virtual rooms where we pack and unpack the boxes for our applications. Servers, however, usually use the permanent ports as a way to create sockets in which it communicates with. But it doesn't always use the permanent ones. The important part you need to know about ports are that they are used for communication and not security. Service numbers have to be well known in order for clients and servers to communicate. So if your web browser on the server is using port 80, then it expects the server to use that port number as well. If the server is using another port, then the web browser will not be able to connect to the server. You would have to specify within that browser to use another port number. This is why 0 through 1023 is used for specific purposes and known universally on the web. Alright, the only other thing that I can tell you about TCP and UDP is that they're not the same protocol. Okay, so if you have an application running UDP 80 and another application running TCP 80, they're never going to meet. They're never going to actually talk to each other or communicate with each other. Okay, the transfer protocols are different, and they kind of pass by each other, but they never see each other. All right. So today we learned that TCP and UDP are essential to transfer data across from one system to another. We learned that we use the transfer protocol to encapsulate other protocols and data in an Ethernet frame. All right. This frame needs an IP address, a transfer protocol, and data to complete the actual packet or frame. We learned the importance and difference between both transfer protocols. We also learned what ports are and how they are used in communicating from one machine to another. The types of protocols that there are, and what we need to create a socket for a client and a server to exchange data. Next week, we'll be doing some practical exercises to help visualize how the IP sockets are used in real-time scenarios. So stay tuned, and remember, there is a quiz at the end of this video. You want to look into the General tab of the Teams application.